Hi, my name is Bob Sipperly, and this is my combined spectral problem video. So the first thing we needed to do was look at the molecular formula and then determine the degrees of unsaturation. So our chemical formula is C9H12. I use the formula of carbons times 2 plus 2, and then subtracted the number of hydrogens from that and divided it by 2. So with that, I took 9, which is the amount of carbons, times it by 2, and then added 2. That gave me the number 18. With 2 added to it is 20. I then took the number 20 and I subtracted the number of hydrogens from that. So 20 minus 12. That gave me a number of 8. And then you divide that by 2, and your degree of unsaturation is 4. So because of that, it made me think that I likely have a benzene ring in this compound. Moving on to the IR spectrum, there's a few different waves that cued me into possible structures within this. Here we have one at about 1600. That made me think that this is likely has C to C double bonds. We also have prominent waves at just below 3000, 2900 to 3000. That's the sp3 hydrogens on the carbons of the sp3s carbons. And then just above that, we have hydrogens that are on sp2 or double bonded carbons. So with that, I could determine that we do have double bonded carbons with hydrogens on them, sp3 carbons with hydrogens on them, and then double bonded carbons as well. With the C13 NMR spectrum, we have a few different sets of shifts, or I'm sorry, shifts that cued me into thinking that we have a benzene ring with possibly a chain attached to it. So the 3 that are a bit more upfield here, that goes from 11 to 39, those are all sp3 carbons. And then further downfield, we have some from 120 to 140. So these are further downfield because they are closer to more electronegative atoms, and they're less shielded. So these in the 120 to 140 range fell into the category of a benzene ring. So this gave me more of an idea of what the possible structure would be like. It's showing that we have 6, what looks like 6 ships. So there could be some symmetry in this as well with the ring, which would make sense. Moving on to our last spectrum, the HNMR spectrum. So we have a few different signals here. Our first one that's at about 0.9, that's an sp3. The next one at 1.7 is also sp3. And then the one that's at about 2.5 is also sp3. And then we have one that's much more downfield at around 7, which is in the area for a benzene ring. So the first shift is a triplet. It's indicating that it has 2 neighboring hydrogens on the adjacent carbon. And this is likely the last carbon that could be in the chain. The next one up that has 2H, but it has a multiplicity of 6, making it a sextet. So that could be in the middle of the chain with 3 neighboring carbons on one side and 2 neighboring carbons on the other, giving it the sextet signal or multiplicity. And then moving more downfield, we have one at around 2.6, which is another triplet but has the integration of 2H. So that could be the one closest to the ring. And then the only neighboring carbon with hydrogens on it is on the chain. So that's why it's a triplet because it only has two neighboring carbons. Then much further downfield, we have the large signal coming from a multiplet. And this has an integration of 5H. So this is likely all of the hydrogens on the benzene ring. And they're all very close together on the signal, and which is why it looks the way it does, because they're all very similar in structure. So with that, I believe that our proposed structure is propylbenzene. So you can see from the IR spectrum that we have the C to C double bonds, but we also have sp3 hydrogens as well as sp2 hydrogens coming off of the ring. With the CNMR spectrum, we have the more upfield sp3 shifts, and then we also have the signals coming from the benzene ring area, and there is some level of symmetry here, so that which is why we only saw three signals. One, these are similar, so it'd be two, and then three. And then with our HNMR spectrum, you can see that the first integration with three carbons and a multiplicity of it was a I'm sorry, it had two neighboring hydrogens on the next carbon. The middle one here was a sextet, and it had five neighboring, two here and three there, adding up to five neighboring hydrogens. And then the next one over was a triplet, and it only had two neighboring hydrogens here. And then that signal coming off of that was around 7 or 8 with an integration of 5 was a multiplet. There's 1, 2, 3, 4, 5 hydrogens, and those were all on the ring. So that's my proposed structure, and thank you for watching.